Section 11.6, arc length and area of sectors. A sector is a region bounded by two radii and an arc. And a picture of a sector is to the right. Bounded by two radii and an arc. An arc is represented by the length from A to B along the circumference of the circle. That would be the arc, and the two radii are AO and OB. How would we find the area of sector AOB in the diagram below? So they give you a 45-degree angle and the radius of 4. So we are looking at what percent of the circle. We're looking at, well, this is 45, and I wonder if we could find the area of the whole circle and continue on to find the area. Let me see, do my notes like yours? Mine are a little bit different. So we're looking at what yours says. We're looking at what percent of the circle. We're looking at 45 over 360 degrees, which is 1/8 of the entire circle. Can you find the area of the entire circle? The area of the entire circle would be pi r squared, which is 4 times 4 is 16, so 16 pi is the radius of the whole circle, and we would only want 1/8 of that. So 8 goes into 16 twice, so the answer for the area of a sector would be 2 pi. The length, which on your sheet they call area A, the length of arc. Notice the arc symbol is a little curvy arc, right? So the length of arc AB would be the length just from here to here. Well, can you find the length or the circumference of the entire circle? Circumference is 2 pi r. R again for this problem is 4. 4 times 2 is 8. 8 pi is the circumference. If you only want this piece of it, it is only 1/8 of it. And 8 goes into 8 once, so the answer for the length would be just pi. In general, the area of a circle is the fraction of the degrees. So it's x over 360 degrees. That would be the fraction of the circle in this of the sector. And you multiply that times the area of the whole circle, which is pi r squared. The length of arc AB is the fraction of the total circle, which is x over 360. You don't really have to have the degree mark because the degree marks cancel. Times 2 pi r. So maybe in green, we remember that this, didn't go to green, is the fraction of the circle. I'll do, I guess, yellow. So this is the fraction of the circle times the area of the whole thing, fraction of the circle times the circumference of the entire circle. And then subsequent, there are some examples which are just like the one we did above. So you do example 2A and you do example 2B, and this is a problem that gives you the radius, it gives you the entire area of the sector, and you have to find the measure of angle AOB. So the sector is 4 pi, which is just this. But what would be the entire circle? Can we figure that out and figure out what percent this is of the entire? Well, the entire circle is pi r squared. R is 6, so the entire circle is 36 pi, the entire circle. And we know that 4 pi is just the sector. So if we were to do 4 pi divided by 36 pi, the pi's cancel. This would be 1 over 9. So this is 1/9 of the whole circle. So we basically have to figure this out over 360. And going forward, what do we get? So 360 equals 9x, and divide both sides by 9. So we get x equals 40 degrees. Final answer, right? Okay. So I'm trying to see if you and I have the same version. Going to the next page. Okay, example 4 are the same. So for example 4, we're given a radius of 4, an angle of 120, and we have to find this piece, which consists of the area of the entire sector minus the area of the triangle. So can we find the area of the entire sector and subtract the area of the triangle? Well, let's see. The area of the sector is the fraction of 120 over 360, which is the entire central angle, and we multiply that times pi r squared. Well, r is 4, 4 squared is 16. I like to put the number first, and that's kind of more traditional. Actually, that is traditional. And then I want to subtract that from the area of the triangle. Oh my goodness. Well, this is an isosceles triangle. So to find the area, we would actually need to find the base and the height. And we're only given one of the sides. But if we were to drop this altitude, we could find the height, because this is now a 60 degree. This is a 30 degree. And this is a special right triangle. And the hypotenuse is 4, which is twice the smallest side. The smallest side would be 2, which is the altitude. 2, sorry, it's a little bit messy. And the side opposite the 60 is a root 3. Well, a is 2, so it's 2 root 3. So the area of the whole triangle is 1/2 base times height. The base of this triangle is 2 root 3, but another 2 root 3. So that's 4 root 3 times the height, which is 2. And we just have to simplify all this. And it's much easier right now to simplify 12 over 36, which is, 1/3. Hello. So this would be 16 pi over 3 minus 4 root 3. This is the final answer. You cannot combine pi's and root 3's, anything like that. Okay? So that's the total area. On your next page, you have these problems. These are like the one, well, this one is like the one we just did. So do this one. And this one is the opposite. In other words, they want the area of this whole piece and leave this out. So if you can find the whole circle, take out the sector, you will be left with this left over. So that the entire circle minus the sector. If you find the area of the entire circle, subtract off the area of the sector, you'll be left with what you need. Hint, it's 2 triangles plus 2 sectors. So this is the only diagram you're given, 90 degrees, 90, 90, and 90. Notice that 90 times 4 is 360 degrees. So this whole, each of these are broken up into quarters of the circle. So when in doubt, draw in radii. And if I draw those in, and each of these are equal pieces, that would force these to be right angles. Oh, I should have actually made it over here. Actually, I'll see if I can make it. Oh, yellow. Fabulous. So that one's a little bit off, but maybe I can move it. Well, I'm making a gosh awful mess. Something like this. So let's see, hot pink, you think? So each of these are right angles. So we can find this area. We can find this area. And we can find the area of these sectors and add them all together. So you do this and try this one as try this one as well, and we'll talk about all this next class.